Good morning students. It's a continuation of the continuity. First question, examine the following function for continuity. First question, f of x equals x minus 5. They are not given at which point we have to show that it's continuous. That's why we have to take x as c, which belongs to some of the real number, where r is a real number. Find, take f of x is equal to x minus 5. So f of c is equal to c minus 5. Next, limit f of x extends to c is equal to limit extends to c. F of x is written as what? X minus 5, which is equal to c minus 5. So both are same. Therefore, the limit of f of x extends to c is equal to c minus 5, which is equal to f of c. Therefore, f of x is continuous. F of x is continuous at all real numbers. It is continuous for all real numbers. Next one. Next one, second one, f of x equals 1 by x minus 5, where x is not equal to 5. Same, let x is equal to c, which belongs to r, where r is a real number. R is a real number. Take f of x is equal to 1 by x minus 5. So f of c equals 1 by c minus 5, where c is not equal to 5. Limit f of x extends to c is equal to limit extends to c. F of x can be replaced by what? 1 by x minus 5, which is equal to 1 by c minus 5. Therefore, f of x is continuous at all real number. It is continuous at all real number. Next, one, f of x equals, the previous one for all real number, all real number except 5 anta baride. Previous one in the baradrala it is f of x is continuous for all real number except 5. Next one, f of x equals x square minus 25 divided by x plus 5, where x is not equal to minus 5. First we have to simplify this. F of x is equal to, this can be written as a square minus b square, can be written as a plus b into a minus b. So x square minus 25 square can be written as x square minus 5 square, which is equal to x plus 5 into x minus 5. X plus 5 into x minus 5 divided by x plus 5, which gets cancelled, isn't it? Which gets cancelled. So the left function will be x minus 5 at x is not equal to 5. Let x is equal to 5, C, which belongs to R, where R is a real number. Where R is a real number. F of c is equal to c minus 5. Limit of f of x tends to c is equal to limit x tends to c minus x minus 5. Replace x by c, which is equal to c minus 5. So both the answers are same. Therefore, the limit of f of x tends to c is equal to f of c. Therefore, f of x is continuous. F of x is continuous at all real numbers. At all real numbers. It is continuous at all real numbers. Next. Next one, find all points. Find all points of discontinuity of f, where f is defined by f of x is equal to mod x divided by x if x is not equal to 0. 0 if x is equal to 0. 0 if x is equal to 0. Is it clear? Find all the points of discontinuity of f where f is defined by f of x is equal to mod x by x if x is not equal to 0. 0 if x is equal to 0. At which point we have to show that it is a continuous function or discontinuous? At the point 0. At the point 0 we have to show that it is a continuous function. So here the point is 0, isn't it? Let us find the f of c first. F of 0 is equal to what? 0. Next, f of x, where the mod x means what? X by x, which is equal to 1 if x is greater than 0. Equals ತಗೊಳ್ಳಲ್ಲ, equals already ಅವರೇ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. Next, minus x divided by x, which is equal to minus 1 if x is less than 0. Why I am taking the plus x and minus x? In the given question it is a modulus of x. Modulus of x is nothing but plus x and minus x. Plus x if x is greater than 0, minus x if x is less than 0. So limit f of x, x tends to 0 is equal to limit x tends to 0, the left hand limit minus x divided by x, which is equal to what? Minus 1. Limit f of x, x tends to 0 plus is equal to limit x tends to 0 plus x by x is equal to 1. So left hand you got it as plus 1, right hand you got it as minus 1, and f of c as 0. So all are the different answers, isn't it? That's why since limit of f of x, x tends to 0 minus is not equal to limit of f of x, x tends to 0 plus, therefore f of x is discontinuous. X is discontinuous at x is equal to 0. Is discontinuous at x is equal to 0. Compulsory you have to write the condition. Is it clear? Next problem. Next one, find all the points, find all points of discontinuous of f where f of x equals is defined by f of x equals x divided by mod x if x is less than 0, minus 1 if x is greater than or equal to 0. We have to show that whether it is a continuous or discontinuous. So let us consider the condition at, we have to show that the point is at the point 0, we have to show that it is a continuous or discontinuous function. Let us find f of c. So f of 0 is equal to what? F of 0 is equal to minus 1. So next take the function limit x tends to 0 minus f of x is equal to limit x tends to 0 minus, which is into the function. For less than 0, what will be the modulus? For less than 0, the modulus will be minus x, isn't it? For less than 0, the modulus will be minus x, which gives the answer as minus 1. Why I am taking the minus 1? X divided by minus x if x is less than 0. The question changes to this form, isn't it? It is equal to minus 1. Now take the right hand limit. Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. The function is constant function. So every constant function is a continuous function, which is equal to minus 1. Therefore, limit of f of x, x tends to 0 minus equals limit of f of x, x tends to 0 plus is equal to f of 0 is equal to f of 0, which is equal to minus 1. Therefore, f of x is continuous at all the points. Continuous at all the points or no point of discontinuity. F of x is continuous at all the point x is equal to 0, all the point x is equal to 0. Next one, prove that every point every polynomial function is a continuous function. Every polynomial function is a continuous function. Remember, ಇವಾಗ ನಿಮಗೆ ಈಕ್ವೇಷನ್ ಕೊಡಬೇಕಾದ್ರೆ x square plus x plus 1 ಅಂತ ಕೊಟ್ಟರೆ it will be the continuous function. x plus 1 ಕೊಟ್ರಾ it will be continuous function. x ಕೊಟ್ರಾ it will be continuous function. x cube plus x square plus x plus 1. So it will be continuous. ಇದಿಷ್ಟನ್ನು ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು ಅಂದರೆ ಒಂದೊಂದೇ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಪ್ರೂವ್ ಮಾಡ್ತೀರಾ. ನಾವು ಯಾವುದೋ ಒಂದು ಥಿಯರಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಮುಂದೆ ನೀವು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ನಿಮಗೆ ನೆನಪಿರಬೇಕು. ಎವ್ರಿ ಪಾಲಿನಾಮಿಯಲ್ ಫಂಕ್ಷನ್ ಈಸ್ ಅ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್. ಎವ್ರಿ ಪಾಲಿನಾಮಿಯಲ್ ಫಂಕ್ಷನ್ ಈಸ್ ಅ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್. ಹೌ ಟು ಶೋ ದಟ್ ಇಟ್ ಈಸ್ ಅ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್? ಲೆಟ್ us take the polynomial equation. ಅವ್ರು ಕೊಟ್ಟಿರಲ್ಲ polynomial. We have to consider the polynomial equation. So f of x is equal to a0 plus a1x plus a2x square plus a3x cube so on plus an x raised to n. Is it clear? So this is a polynomial function where a1, a2, a3 are constants, where a0, a1, a2 so on an are constants. a1, a2, a3 so on are constants, where an is not equal to 0. So we don't know the point. When we don't know the point, always we have to take x is equal to c. Let x is equal to c, which belongs to R, where R is a real number. So f of c, first find the constant. F of c is equal to a0, a1c, a2c square, a3c cube, so on plus an c raised to n. Next, limit extends to c. F of x is equal to limit extends to c a0 a1x plus a2x square so on plus an x raised to n. Now apply the limit a0 a1c a2c square so on plus an c raised to n, which is nothing but what? F of c, isn't it? So limit of f of x extends to c is equal to f of c. Therefore f of x is continuous at all the point of a real number. Therefore every polynomial function is a continuous function. Every polynomial function is a continuous function. Is it clear? Next, every polynomial is a continuous function. So next one, a real function f of x. A real function f of x is said to be, the real function f of x is said to be continuous. Continuous. If it is continuous, if it is continuous at every point. ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಫಂಕ್ಷನ್ ಕೊಟ್ಟಿಲ್ಲ ಅವರು, ನಾವೇ ಫಂಕ್ಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಸೊ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ ಅಂದರೆ ಒಂದು ಸೈನ್ ಫಂಕ್ಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಇಟ್ ವಿಲ್ ಬಿ ಎ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್. ಹಾಗಾದರೆ ನೀವೇ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೋಬೇಕು. ಲೆಟ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ಸ್ ಪ್ಲೀಸ್ ನಾವು ಪಾಲಿನಾಮಿಯಲ್ ಇಕ್ವೇಷನ್ ತೊಗೊಂಡು ಪ್ರೂವ್ ಮಾಡ್ಬೋದಾ? ಎಸ್, ಯು ಕ್ಯಾನ್ ಪ್ರೂವ್. ನಾನಿಲ್ಲಿ ಸೈನ್ ಫಂಕ್ಷನ್ ತೊಗೊಳ್ತೀನಿ. ಮಿಸ್ ನಾವು ಕಾಸ್ಟ್ ತೊಗೊಂಡು ಪ್ರೂವ್ ಮಾಡ್ಬೋದಾ? ಎಸ್, ಯು ಕ್ಯಾನ್ ಡೂ. At x is equal to c, which belongs to R, where R is a real number. So f of c is equal to sin c. Limit of f of x extends to c is equal to limit extends to c sin x. If you apply the limit, it becomes sin c. So limit of f of x extends to c. Sin c can be written as what? F of c. Therefore, f of x is continuous. F of x is continuous. Continuous at all the point. Continuous at x is equal to c or the real number. Is it clear? So we shall do some more problems in the next video. Thank you.